All right, ladies and gentlemen, boys and girls, today we're starting our chapter 7. This is on absolute value equations. If you used to get your equations from Walmart, think again. You used to get equations from McDonald's dollar pick menu or whatever, think again. It doesn't get any cheaper than this today, folks. This is absolute value. And as I know that this is as cheap as it gets, well, let me just say I'm positive that this is as cheap as things get. You won't get that joke right now, but in about 1 minute you will, and you'll realize how good of a joke that was. Anyway, let's get rolling. So today we're introducing the concept of absolute value. I don't really have much else to say about that. You don't know what absolute value is, but we're going to do some expressions that have absolute value in it. We're going to solve some equations that have absolute value in it, and then we're going to get some practice. Basically, it's the same thing we've always kind of done with lessons. Like this isn't really going to be a surprise. One thing I do want to say, because this is the start of chapter 7, you're going to need your chapter 7 booklet. We are starting a new booklet today. And the other thing I'm going to let you know about chapter 7, you can rejoice if you're happy about this. There is no homework assignment during this chapter. This is a short chapter. There's only a few sections to it. Shouldn't take us too long to clear through it, but we're just doing the first section today. Anyway, here we go. All right, so absolute value. In this chapter, we will extensively deal with the concept of absolute value. Absolute value is denoted by two solid bars surrounding a number or numbers, like so. A couple solid bars around a number, right? Well, what does that mean? Well, basically, what absolute value is, it just makes whatever's within those positive. See how good my joke was earlier? It wasn't that good of a joke. I'm just messing around. Anyway, so if we look at this absolute value of 5, well, that's kind of a dumb thing to say, because absolute value of 5 is 5 because it was already positive, so it just keeps it positive. Something a little more interesting, though, if you had the absolute value of -2, well, then that's equal to +2, right? It just makes whatever's inside of it positive. If you want to go really crazy here, what if we said like the absolute value of 4 minus 7? Well, 4 minus 7 is -3, so that's really just saying the absolute value of -3, which guess what? That is +3. Mind-blowing, I know. All right, here's something that you guys are going to absolutely hate in about a week. This is called a piecewise definition. You might even want to write that. Piecewise definition, sometimes called a piecewise function. This is just another way of denoting absolute value. So I'm going to take a second here just to explain what this actually means. The absolute value of A is equal to, and then this big set of brackets, and you just read this as like two separate lines here. The absolute value of A is equal to A if A is greater than or equal to 0. So in other words, the absolute value of A is just whatever A was in the first place, just as long as A was actually positive, right? Or equal to 0, right? It's the same thing. However, the absolute value of A is equal to -A if A was less than 0. And that might sound a little bit backwards, but think of it this way. Let's say A was like, I don't know, -3, right? Then the absolute value of A is going to be, because A is less than 0, we got to use this line right here. It's going to be -A. Well, -A is -3. Boom, it makes it +3, right? So in other words, this negative in front of here just acts as like a -1 to multiply it to turn it into a positive. So you can read that translation there. If the number inside the brackets or inside the absolute value sign is already positive, then it stays positive. It doesn't do anything to it. It's just still A. It's still what it started with. If it was negative, though, then the absolute value function multiplies it by -1 to turn it into a positive. That's really all that does. We're not going to deal with this much today, but later on, we call it a piecewise definition or a piecewise function. And every year, people just hate this stuff. But we'll explain it when we get there. You don't have to worry about it for now. Just keep it kind of in the back of your mind. All right, visualizing absolute value. If you're more of a visual person, think of absolute value as the distance away from 0 a given number is on a number line, is what that should say. It's kind of like glitching out here or something. Anyway, that didn't even fix it. What am I even doing? So anyway, basically the absolute value just tells you how far away from 0 you are on a number line. So in other words, if you had the absolute value of -3, well, then that's 3 units away from 0. Or if you had the absolute value of +3, well, that's also 3 units away from 0. Some people like that definition just to kind of like visualize it a bit. It's up to you, whatever. All right, so we're going to do an example here. This is pretty straightforward example. Write the following numbers in ascending order. If you're not sure what ascending means, it basically just means least to greatest. So in other words, the lowest number to the highest number. Well, to do this, we have to kind of analyze what all these are. So I would get rid of the absolute value bars whenever possible. So on this guy, -8.5, that's just the same thing saying +8.5. 7 is just 7. I'm not going to bother with that one. -6.5 or 6.75 in absolute value bars, well, that's going to be positive 6.75. We got a fraction here. I think we should probably deal with this as a decimal just so we can compare it to the other ones. The absolute value of negative 22 over 3 is the same thing as just positive 22 over 3, which is going to be 7.3 repeating. This guy right here is just going to be 0.01. And these two stay the same, but just for fun, we're going to change negative 4.5 into an actual decimal number. Well, that's just negative 4.5. All right, so if we're going to write these in ascending order, we have to analyze all of these numbers here, all 7 of these numbers here, and figure out what's the least number here. Well, I think the least number here would be this negative 4.5, so I'll write that first. Negative 4.5. You might as well use the original form it gave us. And just as we go along, I'll cross them out, just so I know where I've been. The next smallest number here, I guess, is that negative 0.1. So negative 0.1 is next. I'll cross that out. Next smallest number, and again, use the original one. Don't use the one that you've transcribed it into. It's going to be the absolute value of negative 0.01. So that one's gone. It's almost looking like we're just going backwards, but I think it stops there. The next smallest number is actually going to be this absolute value of negative 6.5. So or 6.75, there you go. So cross that one out. Then the next one is going to be 7. Gone. And then the next one, absolute value of negative 22 over 3. That one's gone. And then the last one, absolute value of negative 8.5. So there it is. Least to greatest, the smallest number to the biggest number. That's about all there is to it. Unfortunately, the rest of this unit isn't quite this easy. You know, this is just kind of like an intro to get us understanding what absolute value does. Remember, it just makes things positive. You know, it's about as cheap as it gets, but that's about all. That's you know, we're gonna have to deal with this a little more. Anyway, let's move on. So evaluating expressions. So when you have an expression, so a whole bunch of things added together, whatever, I just want you to imagine the absolute value function. Oops, uh-oh, didn't mean to click forward, sorry. Just imagine the absolute value function acting like brackets, right? So in other words, perform your order of operations, in other words, BEDMAS, within the absolute value functions first, just as you would solve as if they were brackets. So again, just pretend these are brackets, just they're like brackets that'll make whatever's inside of it positive. That's about it. So if we were to solve this, again, we've got to treat our absolute value bars like they're brackets. So that means we should do them first. This is going to be the absolute value of 4 minus 12, which is the absolute value of negative 8, plus the absolute value of 6 minus 5, which is 1, minus the absolute value of 2 minus 7, which is negative 5. Since there's nothing going on in those absolute value bars anymore, that's like our brackets part is all done. Clearly, there's no exponents here either, and there's no division or multiplication. So we're right down to adding or subtracting. But let's deal with our absolute value bars first. What we got to really do here is we got to say, okay, absolute value of negative 8, that's positive 8. Plus, absolute value of 1 is just positive 1, no big surprise there. Minus the absolute value of negative 5, well, that's just positive 5. So really, we just have 8 plus 1 minus 5, and that's going to be 4. That's all there is to it. Anyway, moving on. All right, so this next example, a little bit spicier. There's absolute value bars covering this whole thing, but then there's brackets within it. You always got to start with the innermost brackets. That's part of the rule of BEDMAS, right? Innermost brackets need to be done first. So let's take care of that first. This is going to become the absolute value of negative 3 times 6 minus 15. Geez, it's embarrassing that I don't have that right off the top of my head. I think that's negative 9. Yeah, that's negative 9 squared plus 22. I guess the next thing we should do is the exponent. Well, negative 9 squared is positive 81. So this is the absolute value of negative 3 times 81 plus 22. Then you got to do your multiplication next. So this is the absolute value of negative 3 times 81, which I believe is negative 243 plus 22. And then that is going to equal the absolute value of, oh, I guess that's going to be negative 221. I really should be doing this with a calculator so I don't make any mistakes. Hopefully I didn't make any mistakes there. If you're seeing this right now, that means I did not make any mistakes, so whatever. Anyway, this is going to equal the absolute value of negative 221, which is just positive 221. Okay, moving on. All right, so now for things to get a little bit more interesting. What happens when we have an equation that has an absolute value function in it? So for something like absolute value of x equals 5, what could be the values of x such that this is true? So the absolute value of something is equal to 5, right? Remember, an absolute value just turns a number into a positive. If it was already positive, it doesn't do anything to it. But if it was negative, it turns it into a positive. With that in mind, if the absolute value of x is 5, that means x could be 5, right? Because the absolute value of 5 is 5. No big surprise there. Or x is equal to negative 5. So really, what we're just thinking here is just saying when you see an absolute value bar equals to something, you just say it's that thing that was inside the absolute value is either the positive or the negative version of whatever it was equal to. So x could be positive 5 or x could be negative 5 because the absolute value of negative 5 is, of course, positive 5. That's a really useful trick that we're going to have to use for a lot of things here. So again, if you can kind of frame it as in your absolute value bars are all by themselves. So this x part in absolute value is all by itself equal to some number. Just consider it equal to that number or equal to that negative number. That's about it. Anyway, moving on. So solving absolute value equations, first things first, get the absolute value portion of the equation completely by itself. That's kind of what I was saying on the last one there. As long as you get that absolute value piece by itself, you're going to be pretty much good to go. Step 2, the value inside the absolute value function will equal positive or negative the other side of the equation, right? You have to consider both, right? You actually have to solve for both the positive and the negative. So this usually gives you 2 possible answers, but here's something that everybody always hates. With absolute value equations, you have to check both answers in the original equation. This is because sometimes you actually get what we call extraneous roots, which are answers that don't really work. I think it was back in the radical unit, that was like the square root unit that we had, that we also kind of found questions like that where you have to check your answers. And I know it's a pain, but as long as you just take a little bit of time just to check your answers, you'll prevent yourself from getting some questions wrong. Because again, not all the answers will always work. Usually they do, but not always. And there's not really an easy way of predicting when they will or when they won't, at least not as far as I'm aware. Anyway, let's start with a more simple example. The absolute value of x plus 3 equals 7. Well, step 1 from before, if I was just going to fly back here, says get the absolute value portion of the equation completely by itself. Well, look at it. It already is on its own. You don't have to do a darn thing, right? That thing is all by itself right here, and then that's equal to 7. So what you do is you set whatever's inside the absolute value equal to plus or minus the other side. So we're going to say x plus 3 could equal 7, right? Because the absolute value of 7 is 7. Or x plus 3 could equal negative 7. Because if this x plus 3 was equal to negative 7, like there was a negative 7 inside of this, the absolute value of negative 7 is positive 7. That's kind of the idea here. Now you have to solve each of these separately. X plus 3 equals 7. Well, if you move 3 over, you're going to see that x is going to equal 4. And on this other one, if you move 3 over, you have to minus 3 from both sides. You'll see that x is equal to negative 10. Now, usually this is a part where I'd box my answers. I'd be like, all right, good, found my x's, I'm done. But you can't get carried away with this. You always have to show that you've done a check. So to check, I'll check each one separately. Sometimes you can clump it together. Like I'll let you decide how you want to organize this. But if I'm checking this one, it's going to be absolute value of 4 plus 3 equals 7. And bingo, bango, bongo, this is just the absolute value of 7 equals 7. I think we can pretty much clarify right there that that one does work. So we're good. As for this other one, we should check it as well. So for the check here, we could say the absolute value of negative 10 plus 3. We want to see if that equals 7. Well, negative 10 plus 3 is negative 7. So the absolute value of negative 7 equals 7. In case you're not already seeing it, well, what is the absolute value of negative 7? Well, it is 7. So 7 equals 7. And capiche, we're good, right? So in other words, I feel pretty confident both of these worked, so I can go back and I can box this one for sure because it worked, and I can box this one for sure because it worked. If it didn't work, we would cross it out. We wouldn't box it. So save boxing it until the very end. I know that's like, even I get in the habit of like boxing it too early, but don't get carried away. Make sure you check your answers. All right, here's one that is definitely a lot beefier looking, but calm down here. This one isn't too much more crazy than any of the others. Step 1 is get the absolute value piece all by itself first. So in other words, we got to undo whatever's happening to that absolute value piece. We got to get that baddie all by itself. So I think what we should do, reverse bedmass this thing. So let's minus 1 from both sides. You got 2 times the absolute value of 7x minus 1 equals 10. Then what do we got to do? Well, we got to get rid of this 2. So we should divide by 2 on both sides. The absolute value is 7x minus 1. That's going to equal 5. Okay, so now we got that absolute value piece all by itself, right? It's equal to a number. So here's where you consider 7x minus 1, the stuff that was inside of it, could equal 5, because the absolute value of 5 is 5. Or 7x minus 1, that stuff inside of there, could equal negative 5, right? Because if this was equal to negative 5, absolute value negative 5, positive 5, and you're all good. Anyway, solve each one of these. We should add 1 on both sides and then divide by 7. So this case would be x is equal to 6 over 7. And on this case, we'd have to add 1, that'd be negative 4 divided by 7. You got x is equal to negative 4 over 7. Now, we got to check this. I don't feel comfortable checking it down here, so you know what? I'm going to put it over in this spot up here. I'm going to go check. Let's check the first one, 6 over 7. You got to plug it back into the original equation. Here we go. So 2 times the absolute value of 7 times 6 over 7 minus 1 plus 1 equals 11. Let's see if this is true. Start in the innermost brackets here. So inside the absolute value, 7 times 6 over 7 is just 6. So then we got 6 minus 1, that'd be 5. So 2 times the absolute value of 5 plus 1 equals 11. Well, 2 times the absolute value of 5 is 2 times 5. That's 10. 10 plus 1 is 11. So we got 11 equals 11. Boom, we're good. So I'll go back here. I'll put a box around this guy. Now, we should check another one. We got to check this negative 4 over 7. So here we go. 2 times the absolute value of 7 times negative 4 over 7 minus 1. I almost said plus 1, sorry, minus 1. And then plus 1. We want to see if that equals 11. Inside the brackets here, 7 times negative 4 over 7. Well, 7 times negative 4 over 7 is just negative 4. Negative 4 minus 1 is negative 5. So we got 2 times the absolute value of negative 5 plus 1. We want to see if that equals 11. Well, the absolute value of negative 5 is positive 5. So we got 2 times positive 5 plus 1. That's 11 equals 11. And look at that. That one works too. You know, it's all nice when they do work, but at the same time, it's kind of like you wish they wouldn't work so that you wouldn't have wasted your time doing the check. But it's never a waste. We always got to make sure that we've gotten the correct answers, right? Because you never know. You never know. They could be extraneous roots. They could just not work. Who knows? Anyway, moving on. Here's another one to try. Matter of fact, if you want to pause the video here and give this one a shot on your own, I would appreciate it. So go ahead and do that. And I'm going to go over it. So here we go. Let's minus 5 from both sides first because we want to get that absolute value all by itself. That's going to be 3 times the absolute value of 3x minus 1 equals 15. Divide by 3 on both sides now, and you get the absolute value of 3x minus 1 equals 5. Now that that absolute value piece is all by itself, let's just consider the two cases. 3x minus 1 could equal positive 5, or 3x minus 1 could equal negative 5. This is kind of looking like the last one we did so far, but let's go a little further here. Now let's add 1 on both sides and then divide by 3. So this is going to be, if you add 1, it's going to be 6. 6 divided by 3, x is going to equal 2. On this one, if we add 1, we're going to have negative 4. Negative 4 divided by 3 is just x equals negative 4 over 3. It's usually easier to leave it as a fraction, believe it or not. Changing it into a decimal can cause you to, kind of get a little wonky later on. I would leave it as an exact fraction and then go from there. I feel pretty confident that we could do a check down here. Let's give it a try at least. So check. We're going to plug in x is equal to 2 first. So we're going to check it into the original thing. So 3 times the absolute value of 3 times 2 minus 1 plus 5. We want to see if that equals 20. Well, this is going to be 3 times 2 minus 1 is 5. So this is like saying 3 times the absolute value of 5 plus 5 equals 20. 3 times the absolute value of 5, well, absolute value of 5 is 5. So that's 3 times 5, 15 plus 5, 20 equals 20. No big surprise there. That one works. So I'll put a box around x equals 2. This guy, however, looks a little suspicious. I'm not going to do my check down here. I'm going to do my check over up here because I got my room. Again, just figure out some room for it and put it in wherever it needs to go. This is going to be 3 times the absolute value of 3 times negative 4 over 3 minus 1 plus 5 equals 20. Starting inside of here, 3 times the absolute value, 3 times negative 4 over 3 is just negative 4. Negative 4 minus 1 is negative 5. So this is 3 times the absolute value of negative 5 plus 5. We want to see if that equals 20. Well, 3 times the absolute value of negative 5 is positive 5. So 3 times positive 5 is 15. 15 plus 5 is 20. So 20 equals 20. And what do you know, that one actually did work too. Holy smokes. See, I called it suspicious for nothing. I was lobbing false accusations against it though. I thought it wasn't going to work, but who knows? See, you always have to check. I thought this one wasn't going to work, but it did. All right, here's another one. We're going to do this one together. Absolute value of x minus 2 equals 3x minus 14. This is the first time where we've seen it's not just equal to a number. We actually have a whole bunch of stuff over here. But this will still be dealt with the exact same ways the other ones were. First things first, get your absolute value piece all by itself. And what do you know it already is? So what we can say is x minus 2 could equal 3x minus 14. Or x minus 2 could equal the negative version of this. So negative, and then in brackets, 3x minus 14. Basically, the idea is if this piece equals this, that's what we're going to consider our positive case, then that's all well and good. But this piece inside of here could also equal a negative version of this, so negative times the whole thing, and that needs to be considered as well. Let's see where we can go from this. We should combine our like terms. I think on this one, I could minus x from both sides. So that'll give me negative 2 equals 2x minus 14. And then add 14, that gives me 12 equals 2x. And then divide by 2, and we're going to have x equals 6. As for this guy over here, we got to get this negative bouncing through this. So this would be x minus 2 equals negative 3x, and then negative 14 is plus 14. Once again, let's gather all our x's. So I'll add 3x to both sides. This gives me 4x minus 2 equals 14. Add 2 on both sides. We have 4x equals 16. And this one works almost too well. Divide by 4 on both sides, and you have x equals 4. Finally, we got some numbers that aren't fractions in here. So this is actually going to be nice. We do have to check both these answers before we box them, though. So we'll go check. Absolute value of 6 minus 2. We want to see if that equals 3 times 6 minus 14. Well, the absolute value of 6 minus 2, I don't think that's going to come as a surprise to anyone here. 6 minus 2 is 4. Absolute value of 4 is just positive 4. This is going to equal 3 times 6 is 18 minus 14. And what do you know? 4 equals 4. So that works. Both sides are equal to the same thing. So x equals 6 is one of our solutions. But we need to check this guy as well. X equals 4. So let's see where this one goes. Absolute value of 4 minus 2. Remember, I'm plugging it back into the original thing up here. 4 minus 2, we want to see if that equals 3 times 4 minus 14. Well, on the left-hand side, absolute value of 4 minus 2 is the absolute value of 2, so that's just going to be 2. We want to see if 2 equals 3 times 4, which is 12, minus 14. But then notice we have 2 equals 12 minus 14 is negative 2. Well, that is not true. That does not work. So I'm actually going to go like not equal, not equal, not equal. This right here shows that we have what we call an extraneous root. In other words, not a solution. So what we need to do is we need to go back to where we said x was equal to 4, and we should just cross that out because it's an extraneous root. It doesn't actually work. So the only solution here is this one, x equals 6, and we're good to go. All right, a couple more examples here. You guys are probably getting exhausted of this already. We're already over 20 minutes into this, but whoop-de-doo, here we go. This one's going to be way quicker than you think. Step number 1, shout it at your screen right now. Very good, minus 9 on both sides. So we're going to minus 9 here and minus 9 here. This is going to be the absolute value of 5x minus 4 equals negative 7. But hold on, ask yourself this. The absolute value of 5x minus 4, you might as well just call that the absolute value of something, equals negative 7. What does absolute value do? Absolute value turns something into a positive number. Well, if the absolute value of something equals negative 7, that doesn't make any sense. This right here is not possible. You can't take the absolute value of something and have it spit out a negative number. That doesn't make any sense at all because absolute value makes things positive, right? So in other words, this is not possible. Therefore, there is no solution at all here. No solution at all. That's it. Okay, so that was an easy one. That was really quite nice. This one, however, not so nice. But we can go over this one together. We can get this one done. First things first, as always, you got to get your absolute value all by itself. So let's divide by 2 on both sides. If we're dividing by 2 here, it just knocks this 2 out. But if we're dividing by 2 here, you have to keep in mind, you have to divide the whole side by 2. So that means you have to divide each of these pieces by 2. This is going to leave us with the absolute value of 2x minus 6 equals This all divided by 2 is just going to be 1x plus 4. Now that the absolute value is all by itself, just consider the positive and the negative versions of your answers. So in other words, 2x minus 6 could equal x plus 4, right? So this piece in here could equal x plus 4, or 2x minus 6 could equal the negative version of this. So I'll say negative, and then in brackets, x plus 4, right? You're just multiplying the whole thing by a negative 1. Solving this positive piece first, we're just going to move the x over. That's just going to make 1x. And while we're at it, we might as well just add 6. So this is going to be x equals 10. And then on this one, got a little bit of extra work to do. We have to say 2x minus 6 equals, bring the negative through, negative x minus 4. So I guess that means I need to add x on both sides. That'll give me 3x minus 6 equals negative 4. Add 6 on both sides. You have 3x equals positive 2. And then that tells me that x is going to equal 2 over 3. Now this is kind of like that one we did a couple slides ago where we ended up having an extraneous root, right? There was like a binomial on the other side. So logic would tell us one of these might end up being an extraneous root. But we'll have to check to see, right? Because it's not always the case, right? It's not always necessarily a pattern like this. Let's find out. So check. Let's check each of these. So we have to plug it into the original thing that's with the 2 in front and everything. So 2 times the absolute value of 2 times 10 minus 6. We want to see if that equals 2 times 10 plus 8. Start with the innermost brackets here. 2 times 10 is 20. 20 minus 6 is 14. The absolute value of 14, yeah, you know what, we'll write it. 2 times the absolute value of 14. We want to see if that equals 2 times 10, which is 20. 20 plus 8 is 28. Well, 2 times the absolute value of 14 is just 2 times 14. 2 times 14 is 28. So we have 28 equals 28. And what do you know, that one did work. Next one over here, we're going to try this x equals 2/3. I shouldn't circle that. That's getting ahead of myself here. So we're going to check this. 2 times the absolute value of 2 times 2/3 minus 6. And we want to see if that equals 2 times 2/3 plus 8. Okay, this one's going to be really sneaky. Start with the innermost brackets here. 2 times 2/3. This is going to give us 2 times the absolute value of 4/3. But then we have 4/3 minus 6. You can't actually subtract something from a fraction unless it has a common denominator, right? So I could write 4/3 minus 6 and then go from there. But really, we got to acknowledge here that we have 4/3 minus something. We should change 6 into something over 3. Well, to turn it into something over 3, just multiply it by 3 over 3. That's going to give you 18 over 3. Might as well write that in one step just so we don't have to write another line with another whole set of fractions in there. That would drive us up the wall. This is going to equal 2 times 2/3, which once again is 4 over 3. And then I could write plus 8, but that has the same issue of what's going on inside the absolute value here. So you know what? We should write this as something over 3. Just multiply it by 3 over 3, and you're going to get 24 over 3. Okay, going from there, let's take care of this stuff inside the brackets. 4/3 minus 18/3 is going to be negative 14/3. So we got 2 times the absolute value of negative 14/3. And this is going to equal 4/3 plus 24/3 is 28/3. Now watch here, the absolute value of negative 14/3 is just positive 14/3. And positive 14/3 times 2 is 28/3. So 28 over 3. That's going to equal 28 over 3. And what do you know? This one actually did work. So in other words, x equals 2 over 3. Both of those solutions work. So just because you have an absolute value thing equals to a binomial like this, it doesn't mean that you're only going to have one solution. Sometimes you end up having 2. That's the logic here. Check your answers. Always, always, always check your answers. You need to do that because otherwise you're going to be in trouble. Anyway, that was a super long lesson today. I apologize, but you guys do need to get some practice at this. So please try page 389, questions 4 to 9. Keep in mind, again, like I mentioned earlier in this episode, I should say, that you did not have a homework assignment for this unit. It's a very small unit, only about 4 or 5 lessons long. So you don't need to worry about that. Anyway, if you need some help, let me know. Other than that, best of luck.